Here's an example using a full 8. You notice that they've balanced the load. They've decided to use 3 boxes of 3, with this one having a spare port that's not being used. So they've balanced the system. But you'll notice the beauty of it is that with this particular design, they decided to have 3 ports. So they're running the 3 set of pipes that will then merge into 2 double singles here, from a single from a double, and then from there run out to the set of pipes to the outdoor unit. But you can go this route, or you could just buy one 8 port branch and have everything in the house run down. It depends a lot on how you think you're going to do this, whether you decide to use 1 or 2 outdoor units. I sized it for both. Obviously, there's a cost involved with running 2 units. That does add quite a bit of cost to the system, but it gives you the advantage that you can place the 2 outdoor units apart from each other if you desire to make the running of the pipe easier. Although for this house, it's simple enough. I don't think you really need to worry about it. But I left that option open to you because I want you to have a little bit of creativity in your own say in this. I didn't want to just force one answer upon you. These outdoor units, the standard units that you'll see when you first start looking at these are good to about 20 degrees Fahrenheit. So they're no good for us because we get considerably colder than that. There are cold weather units available. Generally, they keep their efficiency, that is, the power rating stays good, down to about 0. So that's not too bad. And they can operate as low as 22 degrees below 0 Fahrenheit. So that will work for Watertown. This efficiency, though, is kind of an important bit because Watertown, it does get below 0 for a fair amount of time in the winter, a good 3 weeks if you look at the meteorological data. So you're not going to be running at 100% efficiency, which means that you're using more electricity than what's rated on the Energy Star rating, and that needs to be worked in. If you're honest to your customer, you need to tell them, yeah, the Energy Star rating says it'll cost you $50 a month to operate this. In reality, that'll be closer to $60 or $65. It won't be a lot of difference, but it'll be measurable. It'll be probably about 10 to 15%. If you look at the vendor data that closely, I'm not asking you to, but if you wanted to, you could see it's that close. That's about what it would work out to. These cold weather units should be kept above the expected snow level in the area. So these units should not be set on the ground. That's going to really limit what you can shop for, because most of these units are designed to be ground mounted. You need to find one that isn't. It's a wall mount. And you should also cover the unit for snow protection. And this is a very simple example, but this is actually just an air conditioner. It's not a heat pump. But you can see that this person has put it on a bracket, and they put a little awning over it to keep the worst of the snow off of it. Here's something a little fancier, and this is a heat pump, and you can see that they've put a little snow shield on it. It's a mesh, so you can still get air through it. It's still going to breathe. It won't overheat with this, but it will provide considerable protection. In extreme weather, it may be necessary for the customer to go out and do actual cleaning. This is what you're trying to avoid, because when this starts to happen, your efficiency goes to pot. The house is going to cool off very, very quickly. So this last picture is something that we want to avoid if we can do it. And you do have to have electric backup for the defrost cycle. As you can see, as you might guess, these units are very quickly going to start frosting up. Pardon me, needed a sip of coffee there. So in extreme cases, customer may have to clean, and that should be part of the installation. If you're doing the install yourself, you should show them how to do that. This is kind of interesting. Unlike a lot of systems, with these multi-units, you're going to undersize a little bit. What do I mean by that? We have for heating 54,000, right? So you think to yourself, okay, I need 5.5 ton unit, and normally you would go and just get a 6-ton unit. Not with these. With these, you're going to get a 5-ton unit. That's what you want to get. Okay, so it's going to be it's smaller. These tend to short cycle, and you've been taught what short cycling does. It wears out the electronics. It uses far more electricity than it should, and it means that the house temperature is going to fluctuate. It's a bad situation. So I'm telling you, 5 tons is what you want. Attempt to avoid prevailing winds. Now, let me show you how I did this, and I've already done it for you, and here it is right here. I looked up the meteorological data for Watertown, New York. This is a wind chart of the average for the winter months in Watertown for the past 5 years, and we can see very, very clearly, no surprises, that the wind comes in from the west. It's whipping off Lake Ontario. No surprise there. So we really do not want to use the west side of the home for mounting these outdoor units. If you put them there, I'm going to get grumpy and take points off. So make sure you locate the outdoor unit elsewhere. Here's a quick blow of the downstairs. This is the west wall here, right? And we certainly don't want it here. That's not going to work for us. Ideally, it would be the east wall. And you can see that, hey, that might work. You know, I've got the sliding doors here, but I have, just this one little window for the master bathroom. That unit could go here pretty nicely. And there's room to mount it maybe here. A secondary location would be on this side here. You could, yeah, I know the west wind's going to blow it on it this way, but that would be a secondary choice. But I think the prime location for this outdoor unit is right here or right here. It's along this back wall. Thanks for watching. I hope that helped, and good luck with the project.